Yep, there was a rage quit there. Computer took one for the team, said, I don't want to do this anymore, needed updates, needed shutdowns, needed Windows 11 apparently. I don't know what's going on. I don't use this computer a lot. Okay, so now our range. So the range is going to be where that horizontal asymptote was located. Range where y such that y can't, whoops-a-daisies. Range y cannot be positive 2, y is instead of the real. But like I said before in the other video, we focus more on the domain. Okay, let's have a look at this one. So, if we read up here, we can find the value of the horizontal asymptote if we plug in like really big or really small values of x. The other way you can do it is just by analyzing and saying, well, there's not going to be a horizontal asymptote if the degree of the numerator is larger than the degree of the denominator. So I'm looking at this example and I'm like, hey, this is the difference of squares. And then I can like factor, and then I can like do things, but that all takes me away from what's actually being asked. The question is there a horizontal asymptote? Because the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. Since degree of num is greater than denominator, therefore no horizontal asymptote exists. Okay, so can you still graph this? Absolutely, but if it's a question about horizontal asymptotes, there isn't one. All right, now something new, oblique. Okay, oblique asymptotes. Oh, zut. Did I forget to bold that? Oh, I did. I was supposed to bold and zut. Italicize that. Oh well. It's life. Okay, anyway. So it's a slant asymptote that goes through, there's some weird rules with it. It also goes through the equation of the two first values of a quotient um, of long division or synthetic. So yeah, here we go. New learning. Number one rule, only is going to happen if your numerator has a degree by 1 larger than the denominator. So our denominator highest degree is 1, numerator has a 2, that has an oblique asymptote. If the numerator was a 4, the denominator would have to be a 3. That's a difference of 1, has an oblique asymptote. Okay, so that's how your first check on whether or not an oblique asymptote is going to exist. If you see that the degree in the numerator is 1 larger than the degree in the denominator, you have to do division. You have to divide this value by that and get the quotient, because the quotient is going to give you the equation of the oblique asymptote. It's not just like x equals y equals. It, because it's on a slant, it's the equation of a linear line. So we say, okay, let me make this a little bit cleaner because I was circling when I was talking. Oblique asymptote exists. All right, let's find the equation for that. So we actually have to factor. X plus 1 is going to divide into x squared plus 4. Need a placeholder in there because there's an x missing. Okay, we're going to go with an x times x squared. You can do this synthetically as well. You just know I like long division better because I can see it 0 minus 1 is negative 1x, so then I'd have to put a negative 1 up there, negative 1x, whoops, the daisies, positive 4, that's going to give me a negative 1, there's going to be a remainder here. 4 minus negative 1 is a positive 5 remainder. Okay, so that's great. And the only reason I did this is because we have to take these two values and they tell you what your oblique asymptote is. This is your equation of OA. So that's f of, well, I don't even want to say f of x. It is a function. I'm just going to label it as y though, because like it's a piece of the graph. It's a working piece. It's not a part of the proper graph. I don't know if that makes any sense. Okay, so x minus 1, where we have a slope of 1 over 1, and we have a y-intercept of pink. Yeah, this one looks good. I'm getting all the emails. Okay, y-intercept. Okay, and that's how you would graph your oblique asymptote. Good to know where this lies when it comes to our interval tables and discovering where a graph exists. All right, so let's look at this one. We have degree in the numerator, degree in the denominator are the same. If they're the same, there can be a horizontal asymptote, but the only way that there's going to be an oblique asymptote is if the degree in the numerator is exactly 1 larger than the degree in the denominator. So since degree num equals degree denominator, therefore no oblique asymptote. Awesome, awesome.